Hi students, welcome to Grow Up Online Tuitions and welcome to the class of Neet Chemistry. This is a series of lectures on simple tricks to answer chemistry questions in Neet examination. In this video, we are going to discuss simple tricks to answer questions on bond order. Here we know that the bond order will be calculated by using of molecular orbital theory. We know that by using of molecular orbital theory, that is famously known as MO theory, by using of this MO theory, it will take a long time to calculate the bond order. But in examination now, we have to focus the time also. That's why in this lecture, we are going to discuss simple tricks to calculate the bond order. To calculate the bond order in simply way, you have to know the how to calculate number of electrons in a given molecules or species. Now let us try to know how to calculate the number of electrons in a given molecule or species. Here we know that here they are asking calculate the number of electrons in nitrogen. We know that the nitrogen atomic number is 7. We know that atomic number equal to number of protons. The atomic number indicates that number of protons present in a element. We know that number of protons is equal to number of electrons. So we conclude that atomic number is equal to number of protons and number of protons is equal to number of electrons. So we conclude that the number of electrons present in nitrogen element is 7 electrons. Okay. Now let us try to calculate the number of electrons in NO molecule. Here we know that the number of electrons present in nitrogen, that is the atomic number of nitrogen is 7. That means it will equal to 7 electrons. The atomic number of oxygen is 8. So the number of electrons are 8 electrons. So 7 plus 8, that will give rise to 15 electrons present in NO molecule. In this way you have to calculate the number of electrons in that given species. Now let us come to the tricks to calculate the bond order. Here you have to remember one concept, that is if the number of electrons are 14, the bond order is 3. If the number of electrons are 15, the bond order 2.5. If the number of electrons are 16, bond order will 2.0. If it is 17, 1.5. If it is 18, 1.0. There is a decrease in 0.5 from 14 to 18. Here now let us come to, if number of electrons is 13, its bond order is 2.5. If it is 12, it is 2.0. If it is 11, it is 1.5. If it is 10, it will becomes 1.0. Here the number of electrons are 14, that is 3. Here from left hand side decreases the bond order. Here the right hand side also decreases the bond order. You have to remember this. Then I hope this concept is clear. Here we have to remember the number of electrons are 14, then the bond order will be 3. If 14 to 18, the bond order decreases. From 14 to 10, the order is also decreases by 0.5. Now let us apply this concept on previous year question papers. Now let us see the first question. Which of the following pairs of species have the same bond order? Here we have to calculate the which among the pair having the same number of electrons. That means same bond order. The same bond order, which means having the same number of electrons, that will give rise to the same bond order. Now let us take the option 1. Here oxygen. We know that one oxygen having the 8 electrons. Here 2 oxygen. That means 8 electrons into 2. That will give rise to 16 electrons. 16 electrons, which means bond order is 2.0. Its bond order is 2.0. Now let us calculate the NO plus. Here the nitrogen, which means 7 electrons. Here positive charge present on the oxygen, that will give rise to 1 electron loss. Actually oxygen having the 8 electrons, by the presence of positive charge it will loss of 1 electron, it will becomes 7 electrons. 7 plus 7, 14. 14, which means 3.0 bond order. These two are not same bond order, so option A is eliminated. Now let us come to the option B. Here Cn minus. We know that carbon atomic number is 6. So the number of electrons are 6 electrons. The nitrogen atomic number is 7. So the number of electrons are 7 electrons. Here negative charge indicates the addition of another electron. So total of 8 electron. 8 plus 6, that will give rise to 14 electron. Now let us see the carbon monoxide CO. The number of electrons present in carbon are 6 electrons. Why? Because atomic number is 6. Here oxygen having the 8 electrons. Why? Because atomic number is 8. So total of 14 electrons. That means 3.0 and 3.0. The bond order is 3 in both the species. So our answer is B is our correct answer. I have to calculate the bond order for the remaining for the practice purpose. Now let us discuss the second one. Consider the following species Cn plus, Cn minus, NO and Cn. Which one of these will have the highest bond order? Okay. Now let us calculate the first option NO, which means 7 electrons from nitrogen and 8 electrons from oxygen, sum to form 15 electrons. We know that 15 electrons, which means bond order is exactly 2.5. Now let us see the option B. Here Cn minus, that will give rise to number of electrons present in carbon are 6. Why? Because atomic number is 6. In nitrogen generally having 7 electrons. Here negative charge, which means addition of 1 electron. That means total of 8 electrons. The 14 electrons. The 14 electrons, which means its bond order is exactly 3.0. That means 3. Now let us calculate the third one. Here Cn positive. Here 6 electrons, but having the positive charge, that means loss of 1 electrons from nitrogen. It will becomes 6 electrons. That will give rise to total 12 electrons. The 12 electrons, which means the bond order is 2.0. Now let us calculate the fourth one. The fourth one is Cn. Here we know that 6 electrons plus 7 electrons, total of 13 electrons. Its bond order is 2.5. Here we have to verify which one. Here we have to verify the which option having the highest bond order. We clearly observe that is Cn minus having the highest bond order. So our option is B is our correct answer. Now let us discuss the third one. The pair of species that has the same bond order in the following is. Here also they ask that which among the pair having the same bond order. That means same number of electrons gives rise to same bond order. Now let us calculate the first one. Here carbon monoxide CO, which means carbon having the 6 electrons and oxygen having the 8 electrons. That will give rise to 14 electrons. And second one is NO positive. Here nitrogen having the 7 electrons. Here generally oxygen having the 8 electrons. By the loss of 1 electron, that means presence of positive charge, it will become 7 electrons. So total of 14 electrons. Here 14 electrons, which means bond order is 3, and 14 electrons, which means bond order is 3. According to the given question, option 1 satisfies the given question, that is same bond order having the bond order 3 and 3. You have to calculate the option B, C, D for the practice purpose. Now let us take a look into the fourth one. You have to answer 4, 5 and 6 questions. Please answer these 6 questions. We are providing the PDF in the description box. If you have any doubt, please comment below and send your answer to my WhatsApp number or in the comment box also. Thank you for watching. Please do subscribe for more videos and updates. Please share with your friends and family members. And in the next video, we are going to discuss about the bond dissociation energy and stability. These two concepts are directly depends upon the bond order. By knowing the relation between bond order and bond dissociation energy and bond order and bond stability, you can easily answer the questions on bond dissociation energy and stability. In the upcoming video, we are going to discuss about these two topics by using of a bond order concept. Thank you and all the best. I hope this video is clear to you. Please do subscribe for more videos and updates. You can also follow us on Instagram, Facebook, and Telegram. Thank you and all the best.